Hello, everyone. In this episode of the Basic Turntable Photogrammetry series, I will create a low-poly version of the geometry obtained at the end of the previous episode. I will unwrap and export this mesh so that I can bake the base color texture from the high-poly version in Meshroom. Before we begin, I'd like to remind you that the PDF transcription of all episodes in the series is available for free download at the link in the description. The package also includes the photographs used, with a green background already removed. This is also a great time to subscribe to the channel and enable notifications. First, I save the project, naming it Low Poly to keep a backup copy of the work done so far. I duplicate the high poly object in object mode, renaming it Low Poly, so that I have a copy that retains the same position, orientation, and scale properties as the original. This is necessary because Meshroom requires both versions to be in the same 3D space to perform the bake correctly. I hide the object named High Poly and select Low Poly. There are various ways to simplify or decimate a geometry in Blender. For example, you can use the decimate modifier. In my case, by setting the mode to collapse and the ratio value to 0.05, I can reduce the original 100,000 triangles to 4,994 while still maintaining a good approximation of the initial geometry. By lowering the ratio parameter to 0.01, I reach just under 1,000 triangles while still preserving the main shapes of the geometry. The issue is that decimate will create a geometry with triangular faces and mini poles, as you can verify by applying the modifier and switching to edit mode. If this is not a problem, for example, if the object does not need to be deformable or animated, then you can follow this approach and proceed with unwrapping the UV maps. Here, I am undoing the application of decimate and removing the modifier to show you an alternative method. By switching to sculpt mode, you can use the Remesh tool to simplify the geometry, obtaining a closed object with quadrangular faces. To achieve a good result, it is necessary to set an appropriate value for the voxel size parameter. To determine a good starting value, you can use the sampler within this tool by clicking on a point on the object to understand its typical density. I clicked on a point where the voxel size is 0.001363. To obtain a less dense geometry, I need to perform the remesh with a higher value for this parameter, so I make an initial attempt with 0.01. I'd say I got lucky because on the first try, I obtained a geometry with just 708 quadrangular faces. There are also various add-ons or extensions that allow you to perform automatic retopology, producing only quadrangular faces. However, make sure that the resulting geometry remains in the same 3D space as the original, as I mentioned earlier. Keep this constraint in mind even if you decide to manually create the low poly version. In that case, to avoid mistakes, you could start from the low poly object that was just duplicated from the high poly one, then merge all vertices into a single mesh, proceed with snap, shrink wrap, and other tools to create the new geometry. This way, it will retain the same location, rotation, and scale characteristics as the original model. In any case, the geometry I obtained this way is quite good. I can try to improve the overlap with the original model using a shrink wrap modifier, testing different mapping modes to find the best one. Nothing prevents me from adding extra edge loops if necessary. Once I'm satisfied with the adjustments, I apply the shrink wrap modifier. Now, I can also delete the high poly object from this file. However, before exporting the low poly model, I need to give it a new UV unwrapping so that Meshroom can map colors and details onto two new textures. In edit mode, I notice that there is an edge loop that runs almost perfectly along the XY plane. I select all the vertices along that loop and mark them as seams. In fact, the lower loop is slightly wider than the one I initially selected, so it might be even more suitable. I perform a simple UV unwrapping using the method that seems to produce the best result, meaning the one with the least distortion. This is a simple object with a shape comparable to a sphere, so dividing it into two halves works perfectly as a UV seam. The EXR image is no longer needed, especially since Ramesh has destroyed the original mapping, so I remove it from the shader editor and clean up the file using Purge and Use Data from the Cleanup menu. While I'm at it, I rename the material Low Poly. The Ramesh tool produces a closed mesh by default, so normal shouldn't be an issue, but I check them anyway to be sure. The only thing left is to save a copy of this file and export the model in OBJ format before closing Blender and returning to Mesh Room for baking the textures. That's all for this episode. See you next time.